Yo, welcome to another dev stream after months and months of nothing. I feel like my brain has rotted. There's no way I'm gonna remember anything that we've been doing, like nothing. So that's the project for today, to review everything, basically, or at least have the AI, Gemini that is, ask us questions about the project, and yeah, grade our performance, maybe. Though I suppose that won't be necessary, because there's no way I remember anything. Well, I shouldn't say nothing. I mean, if you look at, let's see here. Oh, there we are. So, I've opened the previous project. I might need to do it again, because it says temporary chat here for some reason. And this isn't a temporary chat. Hold on. Let's open Gemini again. And... alright. There we are. Hello, Gojo. Cool thumbnail. Thank you. It's actually AI generated, though I've been using like my assets as references for it. Like, I tried to do my own thumbnails, but it comes a point when you need to question like your priorities. When even like multi-million subscriber channels like MrBeast can use AI generated thumbnails, there's like no real point in like abstaining from using it myself. So I've been experimenting with using Gemini with their Nano Banana 2 model, and it's surprisingly good. Like, it's pretty insane. Though I suppose most creators use like the Canva AI from the Affinity, but that's a paid service, and I don't feel like paying money when I can use Gemini, which I'm already paying for. So that is very annoying. Where's the Google AI Ultra? I'm not gonna pay, I think it's $300 per month for their top tier subscription. And there's no way I'm paying that. I feel like the $25 or whatever it is I'm already paying is plenty. Had a good start of the week. Let's see. I need to also select the guided learning, I think. Good day? Yeah. Nice. My day's been exhaustive. So, I'm running on fumes right now. Not the best time to review an old programming project, but still. Good git good. Yeah. We just need to... what's the saying? Grin and bear it? Yeah, that's the saying. Just need to grin and bear it. It's another day. Oh, before starting stream, I also ran the file I didn't even remember that we've progressed this far, but it's actually training on the phrase. Where do we have it? Here. Hello AI world. This is a test. We are building a brain. Though even if you're training on it, it's not very smart. Because it's simply printing in a brain. Or a brain. Though... That's randomized, so that should change between generations. We might as well run it again and see what it comes up with. And let's see. Have you made... it seems like the AI is trying to say a brain. It's supposed to read this, but it's getting stuck on this, and if I don't remember incorrectly, it got stuck on building a brain before. I don't know if that's correct, but that's as far as I remember. It's really focused on like the brain aspect of it, the text. But what about your project? Have you made any more progress on the tree harvesting game? Was it a game or was it a simulation of sorts? Let's see. It's been 2 months, or it's been over 2 months since I last looked at Python code, let alone this project. Please start asking questions about what we've been doing so that I can review my knowledge of the subject. Once you feel we've established a I don't know how to prompt this. Quote unquote, a brain length is 8, the same as a variable you have up there. I don't know if that's related, but might be. Which variable? Wait, at the top you mean? The block size. Wait a moment. What is a block? A block? Isn't that what you train on? Like, it's 8 characters and then you're gonna guess the 9th? Or is it that is it 7 characters and you're gonna guess the 8th? And then you can have like multiple blocks running in parallel during the training. Well, the review is certainly needed, that's for sure. Though you might be onto something, Gojo. I don't know. Let's see. Please start asking questions about what we've been doing so that I can review my knowledge of the subject. When you feel that we've covered everything essential, continue with the lessons as planned. I don't know. Let's prompt it with this and hope for the best. I'm also not sure if I should be using like, I think it's called cursor, like a developer environment that has AI built into it, or maybe even Google's own AI. What did they call it? Gravity? I think they call their own developer environment Gravity or something. That might be better in the long run, because using like what's essentially like a web browser like this and then a separate IDE like this, I need to paste the context back and forth, and that's not very efficient. Anyway, alright. Welcome back to the code. Taking a couple of months away means we definitely need to dust off the mental cobwebs before adding new features. We will do a targeted review of the architecture we've built, starting from the input and working our way to the output. Let's start at the beginning of our bigram language model. Language model's forward path. Before the model can communicate, attention, or think feed forward, it needs to process the raw text. When we feed a sequence of characters like hello into the model, we don't just pass in a single ID number for each letter. We look up two distinctive types of embeddings, vectors of numbers, and add them together to create our starting input. Okay, do you remember what those specific embeddings represent? Hint: one gives token its identity, the other gives it its place. Do you know, Gojo? Because I'm not sure. John Python. Well, that's an answer as good as any. Though I don't think it's the correct one. Something tells me it's not the correct one. Well, I don't know. I feel like we need to be honest. I think it's gonna need to start with some more basic questions. I'm wondering if I should like go through all of this step by step. Nah. Let's see what AI cooks up. No worries at all. 2 months is a long time in the coding world, which is exactly why this review is a great idea. When we pass text into our model, we look up two specific things and add them together. Token embeddings. This captures the identity of the character. Identity. It tells the model what the character actually is, like the letter A versus the letter B. Okay. In your code, this comes from self.token embedding table. Can we self.token embedding table? We have two instances of that in the initialization of the bigram language model and inside the forward pass. Positional embeddings. This captures the location. Unlike reading left to right, transformers read all the data at the exact same time. If we don't explicitly tell the model this is the first letter and this is the second letter, it would just see a jumbled bag of characters. This comes from self.position embedding table, which we have here. Okay. So we add them together, x equals token plus position. Okay. Giving us a starting vector that knows both what the token is and where it is. I see. So we're basically training on not only what the token is, but where it's positioned in the text as a whole. I wonder if there's like cross-referencing with the other tokens and their positions. There has to be, right? So we add them together. X equals token. Once we have that starting input x, we pass it into our deep stack of blocks. Inside a block, what is the very first major layer? Inside a block, what is the very first major layer those tokens go through, where they look at each other and share information? Hint, it was the big upgrade we made just before we added the thinking layer. I don't even remember like the quote-unquote big upgrade. I remember we did something that was supposed to improve the model incredibly, and it's certainly doing something. I don't know, man. Like, it's getting stuck on brain, and this is a sentence, to be fair, but it's been trained to only print this for infinity, probably. Like, there's no way it's gonna get out of this loop. And I don't know if this is from a lack of training data or not, because to me it makes sense that if you only have this training data and you train like 10,000 iterations on it, it should be able to perfectly print this again and again and again and again. It's very curious that it's so focused on the last part. Though we do have, when we're generating the 100 tokens here, we're doing a model.generate, and it takes idx, so it loops 100 times in this instance here. I wonder if we could like pass an age, like the starting token, if that would make it print the whole sentence again, instead of getting stuck on the last part. So many questions. Though I suppose I'm getting ahead of myself a bit. Because the question was if we remember inside a block, what's the first major layer those tokens go through where you look at each other and share information? I mean, I could just look at it, right? No one's gonna cane my knuckles for doing that. Though, to be fair, I don't even know what I'm looking at or where I'm looking, because we have a class block. Oh, was it a multi-head? We added multiple heads, meaning we added like multiple eyes, I think. Instead of having like only one eye, like registering everything, we created sort of multi-head attention system where we look at the data from various angles all at once. I do believe that's how it works. Though I could be wrong. Could be wrong. What are we actually doing here? Well, we are initializing the block and setting the SA variable. Is this a variable or is it a something else? Variable, yeah. We're setting the variable to be a multi-head attention class. There are like layers upon layers upon layers of logic here. And I feel like if you don't know like the building blocks, what's on top gonna be very difficult to suss out. What are we actually doing here? We're setting the feed forward variable to be a feed forward class. And it's doing something. It's passing a the number of embedding dimensions. Ooh, I do remember what that is. Interesting. It's passing that through a... Oh, Jesus. Jesus. There's so much going on. This is bad. I felt like I'd lost some knowledge, but I've lost a lot more than I thought. You were like with me at some of the dev streams, Gojo. Do you remember anything about this? It is pretty interesting that the network hasn't dropped yet, as far as I'm aware. There were two reasons for me starting the stream later today. The first one, I had other stuff to do. And the second one is that I wanted to test if the time of day, like the time of day determines if I have network problems during the stream. And it's now been over 25 minutes without a single drop. Like, I haven't dropped a single frame according to OBS. Which is interesting. So either the VPN I'm using gets congested during like early evening, so between 7:30 to maybe 9:15. Or it's my local fiber node. I might be able to do something about it if it's the VPN specifically, but if it's my local fiber node, then I don't think there's anything I even can do about it. So let's hope it's the VPN. Damn it, I should have run a test. Well, I need to test that next stream and see if it's the VPN or the local fiber node. Okay, back to the topic at hand. No. I even tried looking at the master file.py, but for answers, but I feel completely lost. See if it gives us a little more of a grounded question, perhaps? Something that's even more basic. I feel like it's already doing that though. I'm simply retarded. Stupid. Stupid. It is completely normal to feel lost. Taking 2 months away from a complex coding project is like trying to read a book starting from the middle. Let's step away from the code for a second and use an analogy. Imagine a stage play. Token embedding identity. This tells us who the actor is. For example, Romeo and Juliet. In our model, this is the specific character like A or B. Positional embedding, location. This tells us where they are standing on the stage. Stage left, center, etc. Because transformers read all the text at the exact same time without this location data, the words would just be a jumbled crowd. We add these two vectors together, x equals token.position, or as we saw, where did we see it? We saw it here. Token embedding plus position embeddings. I'm guessing this is what it's referencing. So the model knows exactly what the character is and where it is in the sentence. Once we have that starting information, it enters the transformer block. Oh, here we have the code for that. Okay, so X becomes whatever our blocks return after we pass X through them. And the blocks is a neural network sequential. Does that mean it's a sequence of multiple blocks? Oh, I do remember this, I think. This is a sequence of neural networks. And it's gonna pass it from one to the next like the input will go into this one, and then its output will go into this one's input, and this one's output will go into this one's input, and so on until we go to layer norm here. That is familiar. And the class block is a neural network.module. See. Okay. That's a bit illuminating at least. The very first thing that happens inside the block is the multi-head attention layer. Okay. This is the communication phase where tokens look at each other to gather context. For example, the word bank means something completely different if it's standing next to the word river versus the word money. After the tokens communicate in the attention layer, they move to the next layer in the block to think about that new information individually. Wait, are we doing tokenization? We have to do tokenization somewhere, right? Or are we training on the raw text data? Or wait, we're doing tokenization each step even? Maybe? I don't actually remember. Okay. So after the tokens communicate in the attention layer, they move to the next layer in the block to think about that new information individually. Okay, let's see how that looks. Block, so I'm guessing this is simply the initialization. It has to be the forward we're calling, right? When doing the blocks. Or when is that even happening? Are we even calling the forward function? Or is that happening automatically? It's probably happening automatically. Well, it is the first line here anyways. So let's assume it's calling the forward function automatically. And so the next thing it does after doing the self-attention, oh, that's what the SA stands for, self-attention. Then we pass, no, what do we do? Right, we take the old value and add it with the self-attention. So we add the self-attention onto the token? No, to the embedding layer? No. X is the token embeddings and the position embeddings. So it's the information of what it is and where it is. And inside the block we add to that information. We add its relation to its neighbors, we might say. And then we do something else with a forward layer. Self.feed forward. Well, what does that even do? It creates a net, which is a sequential again, with a linear layer, a neural network.relu, and at lastly another linear layer. We are switching something around, aren't we? Like the inputs and outputs. And then we're like flipping the dimensions somehow. after doing whatever this does. Okay. We return whatever that is and we add it to the position data and the identity data and the self-attention data. And then we return that after that's been done. Okay. So do you remember the name of that thinking layer we built right before our break? Hint, we built it using nn.sequential and it looks like a sandwich with linear, ReLU and linear components. The name of that thinking layer. No. Oh. Oh. No. I found it in the master file.python. Is it somehow flipping the dimensions? I'm not clear on why it's there. Because I do remember like we're doing some sort of dimension maths. That sounds way cooler than it actually is, but... okay, so let's look exactly what's happening with those dimensions in the feed-forward layer. Instead of flipping dimensions, this layer is expanding and then compressing them. It's expanding and then compressing. Okay, seems I'd misremember that as well. What does it mean to expand a layer? Here's a step-by-step flow inside the layer. So expand. It takes the token's current dimensions, number of embedding dimensions, which is 32. It is. Is that like a variable somewhere? Maybe we set it down here. 32. That's... Oh my god, I feel like snippets of information is coming back to me slowly. But it's so damn slow. Like I'm remembering the tables. The tables of the dimensions and all of that. Oh wow, okay. And multiplies it by 4. We can see that. Here. But okay, so we're passing the data in and we want data out. So we're setting the features we want and we're saying we want it to quadruple for some reason. And process, it applies an activation function to the expanded data. Compress the text at 128 dimension vector and shrinks it back down to 32 so it can continue through the rest of the model smoothly. Why is it there? The attention layer just moves information between tokens. Like gathering quick notes from a team. The feed-forward layer gives each individual token a large temporary workspace, the 128 dimensions, to actually process those notes and extract deeper meaning before shrinking the final conclusion back to normal size. In your master file, right between the linear layer and the expanded data, right between the linear layer that expands the data and the linear layer that compresses it, there is a specific activation function we added to create a bend or non-linearity to the math in the math. Can you spot the name of that function inside the nn.sequential block? The name of the function is nn.relu. Relu. I'm still not sure about any of this. I think we need to go through the master file.py in order of operations so that I understand it all. I seem to have forgotten even the most basic of basics. I don't know if this is too hardcore, but it does feel like we're simply, I don't know, picking at puzzle pieces that are entirely isolated. You got it, nn.relu is exactly right. That's not the non-linearity that lets the network learn complex patterns instead of just straight lines. Let's absolutely follow your plan. Going through the code top to bottom, following the exact journey of the data is the best way to rebuild your mental model. We will take it one step at a time. Step 1, the data. At the very beginning of your script, before we even build the model layers, we load our text dataset. But neural networks only understand math and numbers, they cannot read English text. Before we pass a word like brain into our model, even Gemini is focused on brain. It likes the brain. Though that might be the context from pasting the result back into, okay. Never mind, I got excited for nothing. We have to convert it into a list of integers, for example, 12, 48, 1, 9, 23. To do this, we find all the unique characters in our text and build a translation dictionary. Do you remember the specific term we use for this process of converting raw text characters into integer IDs? A specific term, tokenization. If I get this wrong, then that's gonna be very embarrassing. Please be right. Please. I beg of you. Yes, okay, nice. Tokenization is exactly right. In your script, we look at all the unique characters in the dataset and build a vocabulary, assigning each character a specific integer ID. Let's summarize the journey of our data so far. So, tokenization. Raw text becomes integer IDs, embedding IDs. I think we're jumping like way forward. Okay. So embeddings IDs become vectors, representing identity plus location. I mean, that makes sense. The blocks. The vectors pass through multiple layers where they communicate, attention, and think, feed forward. When the data emerges from the final block, it is still a sequence of 32-dimensional vectors. However, to actually generate text, we need to translate those internal representations back into our vocabulary to predict the probability of each possible next character. Okay. In your bigram language model's forward function, right after the data passes through the blocks. We're way down here again, okay. It goes right after it goes through one final step called self.lm head. Here, yeah. Final projection. English. Difficult. Let's take a sip of water. Projection. Final projection. Projection. Final projection. Whatever. It goes through one final step called self.lm head to create our final output scores, often called logits. Do you remember what standard PyTorch layer we used for self.lm head to transform our number of embedding dimensions, 32 dimensions, directly into our vocab size, 22 dimensions? No. I wonder if I'm simply continuing to answer in the negative again and again and again when it's asking questions. Will it understand that it's talking of way too complex topics for my feeble memory to even be able to catch up? That is actually a quite interesting question. The layer we use is nn.linear. Okay, in your code it looks exactly like this. Self.lm head equals nn.linear, number of embedding dimensions and vocab size. Where do we have that? Oh, it's inside here, maybe. Oh yeah, here. Okay. Hello, David. Thank you for following. Do you have an interest in Python and AI development? Where were we? Here. Here is why we use it. After the data goes through all the transformer blocks, each token is still represented as a complex 32-dimensional vector, but we don't want 32 abstract dimensions. We want to know which of our 22 specific characters should come next. Hello, what are we building today? I'm trying to catch up on an old project. I'm trying to build my own LLM, and it's been like over 2 months since I last looked at this project. And let me tell you, I don't remember anything. At least it feels like I don't remember anything, but there's a few nuggets of knowledge left, rattling around in my head. But I'm simply doing like a review, having Gemini question me on everything. And when it's asking, do you know what this is? I simply answer no. I have one win here. When it's asking me if I knew what the process for turning raw text into integer IDs were called, tokenization. But that's about it. Not great, but yeah. We need to start from somewhere. Nice, for building an entire LLM model you need entire data center, right? For training a complex or large LLM, yeah, that's true. then you do need like a very large data center, and you need millions and millions of dollars to power it, to train it over months and months of time. So I'm not gonna outcompete Google's Gemini or ChatGPT or Anthropic Claude or whatever. But this is useful for like creating my own AI for maybe game systems, or maybe for having like a tiny assistant or something. So it's not completely useless, but I'm mostly doing it to like learn how it works. I find AI is very fascinating. Very, very interesting. Are you like a developer of sorts? Do you do anything? Python, JavaScript, C++? See, the NN.linear layer acts like a translator. It takes that 32-dimensional thought and outputs 22 raw scores called logits. Each score is essentially the model's vote for how likely that specific character is to be the next one in this sequence. Okay, so grading the model. Now that the model has made its predictions, the 22 votes, we need to check its work. We're doing that here, the loss calculation. See. During training, we feed the model an input sequence like Brai, and it gives us its predictions for the next letter. Since we already know the correct answer is the target. Since we already know the correct answer, the target is in N. N. Where is N? N. Where does... No. It's gonna search in Gemini. But here... N. It's a lot of N's. Damn it. I'm not gonna look through 200 of them. I'm studying AI at uni. Building stuff from ground always feels good. Ooh. You're taking the correct path. Or correct path. The standard path. I'm trying to like imagine how that would even work. I feel like you'd probably sit through like lectures and getting a grounding in functions it calls and different like model types like transformers and all of that, and then maybe it should still come down to a lot of individual work, I'm guessing. Or it depends. University. How advanced are you then? Wait, university is after college. So it's gonna be pretty advanced, in other words. Okay, so this is way... You're probably way beyond what I'm doing. This is probably child's play to you. Unless you just started. Since we already know the correct answer, we can compare the model's prediction against the true answer. If the model gave a high score to the correct answer, it gets a good grade. If it gave a high score to the wrong answer, it gets a bad grade. Do you remember the... Oh, N. N, of course, N, because it's brain. I was looking like N. N is like one of those variable names like I. in my mind, or n like unknown. That confused me so bad. Okay, so do you remember the name of the function we used to calculate this grade or error? The name of the function. I mean, I can just look here. Okay, I'm not gonna look there. Do you remember the name for that function? No, I do not. Hint, in PyTorch we use import as f, and we import it as f, and this specific function calculates the loss by comparing logits and targets. It starts with cross... Damn it, I don't remember. Where are we? Cross entropy. Right. And f is something. It's the functional of the NN. Okay. No. I still have to be honest. Even though it's only for myself. I can't cheat. No problem at all. The function is f.crossEntropy. Here is how it works. It looks at the 22 votes logits the model produced. If the model gave its highest vote to the correct next character, the loss error is very low. If it voted for the wrong character, the loss is high. During the training loop, the model mathematically adjusts its internal weights to make this loss number as close to 0 as possible. That is how it learns. Okay, yeah, that makes sense. Generating text. Once the model is trained and the loss is low, we want it to actually write something. This happens in the generate function at the very bottom of your Bigram language model class. Here is the loop for generating text. So one, first we can look at, okay, here's the generate function. And I don't know what I'm looking at. I knew all of this 2 months ago. It's kind of depressing that's no longer true. We give the model a starting character like T. Okay, the model outputs its predictions for the next character. We pick the winning character, let's say H. We glue them together, TH, and feed both back into the model to guess the third character. But before we can pick the winning character, we have to convert those raw vote scores logits into actual probabilities. Percentages that add up to 100%. Look at the generate function in your master file Py. Do you see the specific PyTorch function we used to turn the logits into probabilities? And it's the softmax. Okay. I do see it. It's the f.softmax. Exactly right. Wow. Wow. It takes those raw, unpredictable scores, which could be anything from -10 to 500, and squishes them into clean percentages that add up to exactly 100%. Then the model picks the winning character, adds it to the sequence, and the whole loop starts over. The complete map. That actually completes our entire tour of the transformer. Here is the high-level map of what we've built. Tokenization text to IDs, embeddings IDs to vectors, identity plus location. Transformer blocks. Vectors communicate attention and think feed forward to build deep context. Output head. Context vectors becomes raw votes, logits. And then we do generation where we turn the logits into softmax probabilities that will give us the next character. Are you feeling a bit more grounded with this high level picture? I mean, sure. I'm more grounded, but this is by no means enough. By no means. If we are to continue this and continue like developing this and adding whatever the control panel hyperparameters. I mean, the control panel is a pretty simple thing to understand what it does, but if we are to like fiddle with parameters and variables and all that, then it's probably a good idea to know what those variables are connected to. So I think the next dev stream is gonna have to be a even more in-depth look at this project. Yeah, that sounds like a plan. Though all of this has like dredged up a lot of buried memories. So I guess it's good to have like a high level overview now for now, and then I can think a bit about this like between now and the next stream. Yeah. Not to mention that I'm very tired still. Not the best day to do this. Well, thank you so much for hanging out today, Gojo and David. Very nice to meet you. And yeah, take care until next time. If you enjoyed it, you know exactly what to do, and yeah, I'll see you in the next one. Cheers!